Hi, my name is Dale Maley, and I built all the amazing hand-cranked wood toys you're going to see in this video. Now these models range from very simple ones to fairly complex mechanisms. There's over 40 of them. So for each toy or hand-cranked model, I will give you the source for the toy idea and the name of that model. I will also then have a short video of the toy or model in action. I don't think you'll ever see so many different mechanisms in one video, so sit back and enjoy. This first model we're going to see, the idea came from a very old 1868 book called 507 Mechanical Movements by Henry T. Brown. Many of the models in this video, the original concept idea came from this book. Should give you a warning, this first one is very noisy, which makes all the kids really enjoy it. Now here's the mechanism in slow motion, so you can see how the gears and the pegs move the yellow bar back and forth. This next much simpler model comes from the book Making Mechanical Marvels in Wood, a 1991 book written by Raymond Levi. This first model is called a self-conjugate cam. Now here's a drawing of the self-conjugate cam from the book, and this device used to be used to step film through motion picture equipment. This next model came from the same 1868 book, 507 Mechanical Movements, and I've called it the pulverizer. Now in this old book, you get a concept drawing or sketch of the mechanism. There's usually a paragraph then which explains how it works and what it might have been used for. And this is the example for number 85 model, which is I've called the pulverizer. So I took that concept drawing and modified it so I can make it into a hand crank model, which is shown on the right. The pulverizer is a smasher on the bottom, and you'll see the purple cam on the right, which is what raises the smasher up and down, as you'll see in a second. This next model also came from the 507 Mechanical Movements book, and I've called it the quarter gear and rack. Now here's a concept drawing for model 131, which you turn the top wheel, has a handle up there, the crank handle. As you turn that wheel, it causes that quarter gear to oscillate back and forth, which in turn drives the horizontal rack gear back and forth, as you'll see in a second. This next model is an example of what's called positive action cams, and it came from this book, Making Mechanical Marvels in Wood. This next fun model is called a single part feed mechanism, and it came from this book, Making Mechanical Marvels in Wood. It's also how old gumball machines used to be operated. Now I call this next model the double fall marble game. And initially I saw a photo on the internet of a similar type of cam driven contraption, but I actually modified the design several times such that the marbles fall two different angles. They fall down first, go around the curve, and fall again, as you'll see in a second. Several years ago, my wife and I took a day trip up to the Chicago suburban area to the Grau Grist Mill, which still operates. And I was fascinated by the wooden peg gears that actually ran that mill. This model actually combines peg gears which have been used for 2,000 years and also more modern bevel gears shown at the top. This next model is called a loose link coupling and came from this book. And the unique thing about it is very simple, but it operates in very dirty environments. It was often used on farm equipment which had dirty environments. This next model is wooden U-joints, sometimes called constant velocity couplings, came from this book. Most cars utilize U-joints, and what they do is as your rear axle moves up and down, the power is transmitted from the engine back to the rear wheels while the wheels are moving up and down. The concept for this model came from the 507 Mechanical Movements books, and it is a type of indexer. In this old book, this particular concept is called Model 232, and it gives you a sketch shown here and also a written description of how it operates. I modified this concept from the old book such that one could make a hand crank model, and my modern design in SketchUp is shown here. You'll see it in action in a second. For each revolution of the crank, the red wheel indexes one tooth. The old 1868 book has another concept for an indexer called Model 65. On the left is a concept drawing for this type of indexer, and then my modern version of a hand crank model in SketchUp is shown on the right. Now we'll see the model in action. Now let's slow the model down to slow motion so you can see how it operates. This next model is called a Geneva wheel, and it comes from this book, Making Mechanical Marvels in Wood. This next model is called the Sun and Planet Gears. It came from the book Making Mechanical Marvels in Wood. It was actually invented by James Watt for a steam engine, so he could get around a patent on a standard crankshaft way back in 1775. This next model is called the Ball and Fork Reciprocator, and it came from this 2012 book titled Building Wooden Machines. This next model is called the Eccentric, and it came from the book Making Mechanical Marvels in Wood. Next model is called Cam and Flower from the Making Mechanical Marvels book. This next model came from the same Making Mechanical Marvels book, and it's called a double slider coupling. This is called a double slider coupling, and in the model the two shafts are about a 1/4 inch offset from each other, yet this coupling handles it fine. This next model also came from the Making Mechanical Marvels book, and it is called a fast return actuator. The next model comes from the Making Mechanical Marvels in Wood book, and it's actually an example of a stationary steam engine. This next model is called an intermittent drive and comes from the Making Mechanical Marvels book. Now on this model, I'm not going to turn it by the crank pin. I'm just going to turn the wheel that's attached to the pin so you can see how the mechanism works. The next model is called a wheel and worm gear mechanism, and it came from this book, Building Wooden Machines. And this was the very first worm gear I ever attempted to make. The gear reduction ratio on this worm gear set is 32:1. That's determined by the number of teeth on the spur gear, which is 32. So it takes 32 cranks of the worm gear to change the big round gear 1 revolution. Back in 2016, I was looking for interesting models to build, and I ran across this YouTube video of this kissing couple model. I really can't remember for sure because this was back in 2017, but I think I saw a YouTube video of this carpenter model. Now I think every so often the carpenter has to take a break from hammering the nail, turn his head sideways to take a look at a pretty girl that's watching him. This next model is called Roller Gearing, and it comes from the Making Mechanical Marvels book. And this is a very neat model because I'm amazed how smoothly it operates. This model always amazes me at how smoothly it operates. Now this clutch box concept came from the old 1868 book. And before we had automatic transmissions, all the cars were manual shift cars, and they used a clutch with a similar concept as what we're going to see in a second. This next model is the same wooden U-joints that we've seen before, which came from the Making Mechanical Marvels book, except this time I chose much more colorful woods to use for the U-joints, so it's a very beautiful model to watch run. Back in 2016, I came across this YouTube video called The Clucking Hens. All four hens exhibit a different type of motion as determined by the cams that operate them from below. Now this model is a modification of a marble dispenser we saw before, except I modified this such that we're using a worm gear and a mating spur gear to actually move the crankshaft back and forth and dispense the marbles. Now normally the chain, like on your bicycle, is made from steel, but this book, Building Wooden Machines, has a pattern for how to design wood chain and wood sprockets. This same book, Building Wooden Machines, also has an adjustable angle U-joints where you can vary the angle the U-joints operate, and you can see that they'll operate with a wide degree of angle between the two shafts. This model lets you adjust the angle that the U-joints operate, so you can see that the U-joints work over a very wide angle. I designed this gear-driven fan back in 2018. And I use gear ratios here to increase the fan speed. So when children crank the handle at the bottom and they get it going fast, they can actually feel wind blowing over their face from the fan blades. So as we near the end of this video, we're going to move to some much physically larger hand crank models. In this case, this is my own design version of a mechanism which has 2 crankshafts and 1 piston. This relatively large model is my own design version of what's called a Whitworth mechanism. I don't remember why I got the idea that I should come up with a hand crank model of a whale that was swimming through the ocean, but you get to see it operate in a second. This is a model of a freight lifting table in green. I actually have some wooden barrels on the top, and you hand crank this on the right. There's a worm gear which drives the red cube box below, and then there's scissors that lift the table up and down. The worm gear has always been a little tight on this model, so you might hear it squeal a little bit. This is a relatively large model that's actually fun to watch operate. It's an alternative way of converting rotary motion into linear motion, and it's my own design. So in summary, this video shows over 40 different ways to have hand cranked wood models. Hopefully this video helps you on some of your future projects. I hope you enjoyed the video, and please subscribe. Thank you.